Okay, let's take a look at the reaction that is between these two. So you got sodium chromate and you have silver nitrate. So let's write it out. We have our solubility rules right here. So I have my sodium chromate. All right, let's talk about it. Clearly I can see it's a solution. There's nothing on the bottom. But if I look at my solubility rules, it says that chromate is slightly soluble. According to that, that should make this a solid. But that's not the whole story. You have to look at the cation as well. And the cation is a sodium ion, which is an alkali metal. It says most salts containing alkali metals and ammonium are soluble. So because the sodium is bonded to the chromate, this automatically elevates it to being soluble. So it's AQ. Okay? We're going to react it with silver nitrate. And that looks like a liquid as well. It's kind of hard to see. But nitrates are always soluble. Okay. So now, it's a double replacement reaction. So we need to switch the cations and the anions with new partners. So let's just switch the sodium and the silver. So I'm going to put silver right here. That's going to be with my chromate. And my sodium is now going to be with my nitrate. Now you saw the reaction, and the reaction made a precipitate. So in theory, you are very confident that there's a precipitate, a solid, as a product. So some of this you wouldn't even have to have memorized anymore. If you just simply memorize it, either alkali metals are always soluble or nitrates are always soluble, you know that this is my aqueous solution. And that means the other one has to be a solid. But if you didn't see the reaction, then you'd have to have a little bit more knowledge on the fact if this actually made a precipitate. So first we got to get this right. Because this 2 was here, that means that this is a 2 minus, so it's got to come down. So that's actually the proper formula. So now I have 2 AGs, 2 AGs, 2 NO3s, 2 NO3s. All right, so let's look at our solubility rule so we understand this. It says chromate. I always look at the anion if I can help it. Chromates are slightly soluble, and there's no other exceptions, and AG is nothing worthwhile that will help it become an aqueous solution. So this has to be my solid. Okay, what if I was talking about it in terms of ions and the net ionic equation? So anything with AQ has to be an ion. So I have Na+, I have chromate, and I had 2 of those, so I'm going to put a 2 right away. I have 2 silvers. I have 2 nitrates. So those are my reactants. My products, because that is a solid, that stays together. I'm going to write solid. Why did I not write AQ? Because if it has a charge, you assume it's AQ. Because this is a solution over here, I write that. The 2 applies to all of this. The 2 here only applies to that AG. The 2 here applies to the Na and the NO3. So that is my overall ionic equation. What is my net ionic? That deals with crossing out spectator ions. And a spectator ion has to be in the same exact form. So I can't have, this doesn't work. If you have an Na plus here, and then there's an Na here. Reason why is that this is AQ, and this would be a solid. So you got to be a little bit careful about that. So that does not apply. So I do have an Na plus and an Na plus. I do have a CrO4 minus 2 here. 2 minus? Nope, I don't have that here. I have an Ag plus? Nope. Oh, NO3 minus, NO3 minus. So what's left are these 2 ions making up the solid. It is best practice to write the cation first, the positive ion, the anion, the negative ion second. You know you did it right if everything balances out. So let's double check, and I want to be very clear on what it means to be balanced. I have 2 AGs, 2 AGs, 1 CR, 1 CR, 4 O's, 4 O's, The other thing that matters is charge. So I have no charge here. So my charge here is 0. Here I have 2 plus, and here I have one of these, which is a 2 minus. So that negates the 2 to make it a 0. So to summarize that, I have the same amount of elements and the same charge. So this is my net ionic equation. All right, so let's take a look at our actual reaction we just had, right? So we had this beaker. This is really important. Can you actually draw it at a particulate view, meaning like the atoms or the elements or the ions? You break it down. So I'm going to make a little smaller one here. In general, right, we had a solution basically with my solid, right? It was red. So what's in the solution? What's in my solid? We don't know how much we had of each, so this is not a quantitative question. This is a qualitative, so just what's present in general terms, okay? So again, I have my double replacement reaction here. I have my overall ionic equation here. So some of it is easier than others. So if I ever ask you to do this, which you will have to, a lot of times you start with the precipitate. So this is my silver chromate. But what's present in my solution? Okay, well, you got to be mindful that all of this right here is my product. So this is after the reaction is done. So this is what you focus on. You do not focus on the material beforehand, okay? So I know for a fact that I have some Na plus floating around, and I don't know how many right now. We don't have to worry about that. I also have some NO3 minus floating around, okay? And then here's the key. You're either going to have some Ag plus, you're going to have some CrO4 minus, unless if this was a perfect reaction. So if I were to tell you at the beginning, I'm going to make this up right now. Well, it's actually not really all that made up. I poured a bunch of this in. So this was in the beaker first, okay? And then I used a pipette for that. So if I told you that, I would hope that you think, yeah, you know what, you probably had less. So that's my limiting reactant. So what does that mean? Why did the reaction stop? It's because one of those ran out. So of those two ions, which one would run out? It's the one that's creating something new. So all you'd have to say is, oh, the limiting reactant was silver nitrate. Well, the product has silver in it. So this is going to run out. So this is limiting. And the minute I say limiting, that means I'm going to run out. So it would make sense that my other ion would probably be, sorry, this is a little sloppy, would be the chromate. If this was the limiting reactant instead, and silver nitrate wasn't, then this wouldn't be in the solution and Ag would be. But because of the fact that I had it poured into a beaker and then I used the pipette, that would probably be my best guess. So that is what we call a particulate view, or we look at it through the particles and the ions, and you can better explain and see what is present at a chemical level in a solution. All right, here's another chance to do some practice. This is going to be your Polyatomic Ion Quiz for the first day of class. So if you have cohort A, you are going to be in school on next Tuesday, and cohort B is going to be this coming up Thursday. So this is an example. Obviously, there's other things that could be asked besides these, but all of the polyatomic ions are on the table. So if I give you 10, if I give you 12, how could you do this? You got to come up with the names, or you got to come up with the formulas, okay? So it's going to for surely be 10. It could be 12. So I would suggest pausing this, work through this right now, please. I'm going to begin and show you the answers, and obviously you could look this up, but I'm going to help you with a few of them in case you can't remember, okay? So pause it and work on them. Do the best you can. Don't cheat. All right, so hopefully you've now worked on these. Let's talk about this. So this first one, it's got to be nitrate or nitrite, right? If you've studied this at all, you got to know it's one or the other. So let me give you the first idea, or the first cheat that you can kind of have, is that you have 2 minus charges and you have 1 minus charges, okay? If you can memorize this, this charge is larger, a 2 versus a 1. So 4 O's is almost always an 8 for that, okay? And for -1, you always have 3 O's for the 8s. Okay? So 2 is bigger than 1, 4 is bigger than 3. So if you can just remember 2 and 4 and 1 and 3. If you can't, we'll try to come up with something else. So I have a -1 here, and so that means a 3 would be 8. So there's only 2. Ites are less than 8s. So this is nitrite. Because some of them don't work that way, and that's okay. There's only one carbon something, carbonate, carbonite, in our ions that we have to review and study. So that is just carbonate. Okay, here's another one. SO4 2 minus. Is that sulfate or sulfite? Oh, it's 2 minus. Oh, it's not a 4, it's a 3. It's 1 less. So that is sulfite. Okay, these are harder. The chlor, there's 4 chlors. Hypochlorite or chlorate, chlorate, chlorite, hypochlorite. So it's, I said that wrong. Perchlorate, sorry. Perchlorate, chlorate, chlorite, hypochlorite. But -1, 3s are the 8s. It's 1 less. So this is chlorate. Got a lot of ites in this so far. All right, chrome. If you're studying this one, we either have chromate or dichromate. There's only 1 chromium there. So this has to be just chromate. This you need to memorize. It's ammonium. Okay, how do you get half points? The only way you can get half points is if you have the ending wrong. So if you wrote nitrate, you get a half. Carbonite, you get a half. Sulfate, you get a half. Anything else, that's all off. All right, coming on this side. Let's talk about the ones that are really easy. And I'm going to set you up in the beginning. So phosphate, that's PO something, right? Acetate, don't have any idea at the moment. Chlorate, ClO something. Hydroxide, it's oxygen and hydrogen, so it's O and H. Cyanide, that's a little tougher. We'll go back to it. And then, again, chlorite's in there, so that's Cl and an O. So let's go back. Phosphate, unfortunately, you got to kind of memorize that one as well. So ammonium and phosphate don't fall under really anything. So that's PO4 3 minus. Why you have to memorize them is that because this is a 3 minus charge, and most of what we're looking at are not in a 3 minus realm. They're -1 and -2, and this is a +1, so that's why that makes it bad. This one most of you will not like. It's acetate. Excuse me. Acetate. Acetate. So 3 syllables, 3 letters. C2H3O2. They're a very nice trend, right? Very symmetrical. So 2, 3, 2. And that has a -1 charge. Chlorate. Okay, now, how do I know how many O's and what's the charge? This is where, if you're stuck, this could help you out. If you look, chlorine is in group 17 on the periodic table. That is odd. An odd number gets a -1. An even number gets a -2 if you don't have this memorized. It said 8. Well, what do -1s have with 8s? 3, right? -1 8s. That's how I would have done that. Hydroxide's kind of easy one to remember, but if you can't, it's the most direct. So oxygen as a charge is -2 and hydrogen as a charge is +1. So if you do the math on that, it becomes a -1. 1 minus 2 is -1. Cyanide, you're just going to have to kind of work on that one as well. And then hypochlorite, let's talk about that. So if chlorite, which we have over here, if chlorite is this, and they're always going to have a -1 charge. Look at chlorate, chlorite. That's what that one is. Hypo, like hypoglycemic, you're low on sugar. So you have less. What is less? It's less oxygens. So it's just that. Okay, so that's just yet another example and another opportunity for you to practice. So we will be having a polyatomic ion quiz on the first day of school. It should be quick, and you should have been studying this whole time. So hopefully you can do your own quizzes. Have your siblings or your parents help you out and ask and use note cards, okay? All right, let's go over what a solubility quiz, solubility rules quiz would look like. This is not necessarily the exact questions that I could ask, but this is how I'm going to kind of set you up, okay? So first, you're going to notice that it's really important that you know your polyatomic ions, okay, and you know your charges. So we can definitely go over that a little bit again, but you're going to have that down somewhat. So we have our solubility rules, and I've been saying this throughout the summer. is that honestly, if you can memorize these three, or even just these two, you have a pretty good chance at doing very well on this quiz and understanding it whenever you do it. So always know nitrates are soluble and alkali metals are soluble. You'd be amazed at what that does, because what you assume is that there's a solid in there, and I'll show you in a minute. A bonus is if you know that halogens are soluble except with Ag and Pb. I'm ignoring mercury because most things, most reactions that we see, we do not utilize mercury because of how toxic it is. All right, these other things do matter, and we'll see it. So first I need to make my reaction. I'm going to not emphasize if you get the formulas perfectly right, you probably won't get a perfect score, but you could get a very high grade regardless. So first off, the lead's gonna be with the sulfate and the ammonium's gonna be with the phosphate. So I'm gonna just switch the lead and I'm gonna put the sulfate with it. And I'll talk about how I got that in a minute. The ammonium is gonna be with the phosphate. Suggestion, you can write charges on the top. So I know ammonium, it's written right here, you don't get to use this though, is +1. Sulfate is a 2-. So that means that the sulfate has a 2- on this ion now, and the ammonium's carrying a 1. Lead has a 2+. Why? Because of the Roman numeral. And then phosphate is a 3-. And again, it's all written right here for now. So when I crisscross, you got to make sure you're doing this right. So this is 2 and 2, so that maintains. And this is a 3 and a 1, so the 3 has got to come down. Okay? To be totally blunt, I don't always have all of the exceptions memorized, but I do have other things down. Like I know ammonium is always soluble. So right there, it's soluble. Even though the phosphate says it's slightly, this gives it a bump up. So this is automatically AQ. So if you were told a reaction occurs, this has to be a solid then. A reaction means a solid formed. Now, if it asks, determine if a reaction was formed, there could be 2 AQs, but there can never be 2 S's. So if you found the S, the other one has to be AQ. If you found an AQ, you got to make sure that's an S. Okay? I am not caring about balancing right now. Technically, I'd have to balance it, but it's kind of awkward to balance formulas with words. Okay? And I'll tell you now, if I do this, I might have like, I'm going to make this up, like 2 of them are with words and 2 of them are with formulas, so it's easier for you. I do all formulas, depending on our amount of time we have. But let's just move forward with this. So I have silver hydroxide and calcium sulfate. So let's switch the silver and the calcium. So I'm going to have the Ca with the OH. I'm going to have the silver with the sulfate. Again, let's check charges. So silver is always +1. That's one you have to memorize. Reminder, silver is always +1. Zinc is always +2. Those are the only 2 that you can't get strictly from the periodic table or Roman numeral. Hydroxide is -1. Calcium is 2+ because it's in the second column. And then sulfate is a 2-. So this is a 2 to a 1. And this is a 1 to a 2, so the 2 comes down. So if you're not sure, for right now, we might have to look at the solubility rules. So you may not be all that comfortable with this one. I think this one might be the hardest one on this sheet because it doesn't deal with a nitrate, it doesn't deal with an alkali metal or a halogen. But I said if you memorize these 3, especially these 2, you'll get about 80% of them automatically done and correct. Because if you find that that's AQ, you can a lot of times assume the other one's an S. But in this case, let's look. Sulfates, I always look at the second part, either one. Sulfates are soluble, hydroxides are slightly. Okay, there's a lot of wording underneath it though. Exceptions. The BA, PB, no, I don't see AG, so that automatically has to be an AQ. Why did I choose to do that one first? I have no idea why. Hydroxide, slightly soluble. Ooh, that means it's going to be a solid, except, wait, hold on. Soluble if it has this? No, it doesn't have this, and marginally is even worse than slightly. That means it won't really dissolve. So this must be my AQ, or my solid. Solid. Because it's slightly soluble. And I'm not worried about balancing. Okay, let's keep going. And at any time, please pause if you want to work ahead without me. That would be fantastic. Let's talk about charges. That's a 2+. Chlorate's a -1. Sodium's a +1 from the periodic table. Iodine is a halogen. It's a -1. So I only have one difference in charge, so the PB's got to come down here. So again, nitrates and alkali metals. That's an alkali metal, automatically AQ. Halogens. Notice I keep looking at the anion first, though. Halogens. Oh, there it is, iodine. Soluble. Except, hey, PB. PB is with iodine. It's got to be my solid. Sodium is now with chlorine. Iron is now with phosphate. I have a +1, -3, a +3 because of the Roman numeral, and a -1. So, oh, the 3's are together, the 1's are together. Sweet. So, right away, this has to be AQ. How do I know that? Na, soluble. I'm done. I don't have to worry about it. But Cl is also soluble when it's not with these. So, it's definitely soluble. Let's look for this one. FePO4. I look for the PO4. PO4, 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 PO. Oh, here it is. Slightly soluble. So if it's with a completely soluble and a slightly, this will become my solid. Last one. Potassium, sulfate, barium chloride. Potassium is now with the chlorine, so KCl. Barium is now with the sulfate, BaSO4. +1, -2, +2, -1. They all work out. 1, -1, +2, -2. So alkali metal, halogen, same concept, AQ. BaSO4, SO4, soluble, that's AQ. Oh, wait, exception, BaSO4. Okay. Let me just show you one in case, because I didn't get to any that would look like this. What if you had this problem? I'm making something up here. It's not a great example because this is not really all that soluble in the beginning, but if you assume these were AQ in the beginning, for some reason, they worked. When you mix them up, let me just show you. I just want to show you the products. Focus on this. Don't worry about my beginning part. If these were your two products, what would you do? Well, lithium, alkali metal, automatically soluble. I keep trying to show you. If you just memorize the first two, you're going to be pretty good. Lead nitrate, lead nitrate. Oh, it's the nitrate. Nitrate, soluble. They're both soluble. No reaction. So, usually if you get an AQ, you can assume the other one's an S, but not always the case. So I hope you've been understanding this a little bit and working on that. If the charges stress you out in the crisscrossing, although that is not what I'm testing you on, that is important. If you would get all of these states of matter correctly, but you had your crisscrossing or your formulas incorrect, let's just say that the quiz is worth 10 points. I probably would dock you maybe 9 out of 10 or maybe an 8 out of 10 depending on how egregious your errors were. But you'd still come out of it okay.